So last time we talked about trophic ladders and the organization of organisms and the flow of energy. That's what trophic means. What we're going to do today is try and make them a little more complex by looking at them as food chains and webs. And this will explain more about the health of the ecosystem and the balances that exist in there. So let's just review. I don't think you need to write this down, but I just want to quickly remind us that it's all about the movement of energy. And there's two different ways that we can get energy into the trophic ladder. One is directly from the sun, obviously. And the other is by one organism eating another organism. So last time we learned that autotrophs, like plants, some protista, some bacteria, get their energy directly from the sun and build it into food. They make their own food. And then their food gets transferred, or the energy of it gets transferred into primary consumers, secondary and tertiary. And the simplest way of looking at it is that a primary is probably an herbivore, someone who just eats plants. A secondary up here would be an omnivore, someone who eats plants and animals, and a tertiary might just be a carnivore. Doesn't have to be that way, but that's just one example. And then after the consumers die, the energy goes into the decomposer, like a worm or a bacteria or many insects that are in the ground, mushrooms and so forth. And they take the organic matter, put it back into the ground, and then it's once again utilized by the producers. So this is just a summary of what we just talked about here. Autotrophs and heterotrophs, and then these are all different types of heterotrophs down here. Okay, so last time you had an assignment where you took a biome and you found different organisms from it and put it together into a trophic ladder that followed the flow of energy there. We can think of this trophic ladder as being a food chain. So food shows who gets eaten by who, but really what we're interested in is the transfer of energy. So the energy started here at the sun, and we have a producer here, for example, grass, that utilizes the energy. Grass is then eaten by a primary consumer here, which is an herbivore, who's then eaten by a secondary consumer, who's a snake, an omnivore, and then a tertiary consumer, like a hawk, carnivore, eats that. Now, why is the hawk called a tertiary? Because if you look at the number of steps it is away from the grass, it would be 1, 2, 3 steps away. So it's a tertiary animal. Now the hawk eventually dies, and its energy is decomposed by fungi, and those nutrients are returned to the grass, and that completes the entire chain here. Now that's a single chain. What happens if we have an ecosystem which is more complex, that has lots of chains in it? And often there are organisms who overlap within the food chains. So you end up with a food web. The more and more connections you have here, it more has a look of a web. Now if you look at these web parts, they look like arrows. What do the arrows actually indicate? They indicate the movement of energy. So in this case, the energy from the algae, right, goes to the tadpole because the arrow goes that way. Now some people like to say the tadpole eats the algae, but I think it's easier to just think about it as which way the energy goes. Now, let's go ahead and dissect this a little bit, and let's see if we can follow one food chain. Now, I'm not expecting you to draw this whole thing down here. All I really want you to understand is the big ideas. Idea number one. A food web is really a combination of many food chains which overlap. So you can see that some of these guys, for example, the sedge, actually has arrows that go to many places. Same thing over here with the frog. There's arrows coming and going to many places. Okay, let's go ahead and isolate one single food chain in here. I'll go ahead and use red. Why don't we start with the sedge? So that's an autotroph or producer. It gets consumed by the moth. That's a primary consumer. So let's follow that. Then that guy gets consumed by the frog, a secondary consumer. And the frog gets eaten by the kookaburra bird, who's a tertiary consumer. So that would be one chain within this whole web, right? Okay. Now there's lots of different chains in here, and sometimes you find that the chains actually overlap. And each time they overlap, you have to check, because it may be that that organism was serving a different role. So that's our second big idea. The same organism could have different niches within this food web. Let's take a look at the centipede, for example. So I'm going to follow through red again. So we have decayed material, right, from a decomposer, which is going to a centipede. Okay, based on that, the centipede would be an herbivore. It is a primary consumer, based on that. But could have happened another way. Let's use a different color here. How about blue? Suppose we start with a producer like the sedge. The sedge is consumed by the ant, an herbivore, which is a primary consumer. And then the ant is consumed by the centipede. Now in this blue food chain here, the centipede would be a omnivore or carnivore. It would be a secondary consumer because it is 1-2 steps away from the producer. In the other guy, it's a primary consumer because it's only 1 step away. Now, here's the third most important idea. The more connections you have, the healthier, the more stable the ecosystem is. In particular, for any organism, the more arrows it has going into it means it's going to be safer. Why is that? Well, let's look at the centipede. Suppose, for example, the ant population dies out. It still can rely on eating decayed matter, so it doesn't die. It simply changes its food source. And that's the same with a lot of these guys. Look at the frog, right? The frog might select, let's just go ahead and clean this up here for a second. The frog might go ahead and use ants as its food source, right? But if the ant population for some reason goes away, it's still okay because it could survive on moss. So the more arrows, the more combinations, the more web we see, the healthier and safer this ecosystem is going to be. Okay, let's finish it up, put it all together, the 10% rule. Unfortunately, every time you go from one organism to another, every time there's an arrow, it obeys the 10% rule. This means that only 10% of the energy, on average, is transferred. You lose 90% every time you go from one trophic level to the next. Wow, that's incredible. So let's go ahead and think about those 3 levels before. Going from the producer, right, to the primary consumer, you only end up with 10%. You go to the secondary consumer, you only end up now with 1% of the energy. You go to the tertiary consumer, like the carnivore, you only end up with 0.1% of the energy. Wow. So by the time you get to some carnivore, like us, or like eagle or something, you really have lost a ton of energy. For this reason, right? For this reason, it really makes sense for poorer countries to concentrate on growing crops rather than raising animals. Because the animals are higher up the trophic level, they have to eat the crops, and they're going to lose 90% of their energy before it gets into them. And that is why if you're in a very wealthy country like the United States, we will actually grow wheat just for the purpose of feeding it to cows so that we can eat the cows. We lose a ton of energy as we go through that trophic level, but we've got energy and money to burn. If you were in a much poorer country, you'd probably spend your time and money growing a crop and eating it directly, like rice or like beans, and not go through that whole process of feeding it to animals so that you could lose all your energy simply because your culture preferred to eat that type of meat.